Now we are going to talk about why we needed to do that experimentally, because when I look at this, if 2 moles of nitrous oxide go away and 1 mole of oxygen goes away, I form 2 moles of nitrogen dioxide. And so somehow we should think that our rate is tied into stoichiometry. However, this is an overall reaction, and what we found as chemists is that even though this is the end result, this is not how it actually happens. So reactions a lot of times are broken down into their elementary steps. Okay, so first, 2 nitrous oxides combine to form dinitrogen dioxide, and then that combines with oxygen to form nitrogen dioxide. So we have 2 steps that happen. And that's why we need to figure out our orders from experimental data. If we knew what the elementary steps were, we could figure out our rate law from that. Now, our steps don't always happen at the same speed. And our reaction is only as fast as our slowest step. So this guy is so slow, it doesn't matter how fast that is. This guy is what determines our rate. So our rate law actually comes from our slow step, and that's called the rate determining step. And when they tell you what's fast and slow, they'll ask you what's the rate determining step, and that's the slow step. That's all you need to know there. You also need to know that our rate law comes from the slow step. So here we wouldn't know what our elementary steps were if we were just given this equation, which is why we need to determine things from experimental data. Now, the other thing to notice is that these 2 elementary steps add up to this equation. You will not have to do that. You will have to recognize, though, that dinitrogen dioxide is not in our overall reaction. Why? Because it's formed, and then in the next reaction, it's used up. So it's really seems to us like it's non-existent, although it's there and then gets used up again. And that's called an intermediate. And you will have to determine what the intermediate is when they give you these 2 steps. So that is something that is formed and then used up in another step.